Hey everybody, this is Larry. This is day 11 of the Leetcode Daily Challenge. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about today's problem. Remove duplicates from sorted array 2. So I usually solve these live and especially with the explanation as well. So feel free to watch in 2x or skip ahead if you like. Okay, so basically remove duplicates. Okay, so appears, okay. So basically you remove more than 2 copies, is that right? So you have at most 2 copies of each number, but they're sorted. So I actually don't know what remove duplicates from sort array 1 is, but I think it is still the same idea, which is that you just have pointers and you have to keep track of numbers to make sure that it doesn't appear more than 2 times, right? And you could do that in a number of ways. And maybe if you want to generalize it, that's okay too. The way that I'm going to do it is just doing a couple of if statements. But I'm just looking at it because it looks a little odd. Because I'm trying to figure out what the input is symbol, I suppose, but the output and the number. Okay, so I think I have an idea what this is saying. This is asking for, because you want to modify it in place, you want to return the number of elements in the final array, and you could just return the array, but I suppose they only care about the first 7 items in this case. So basically the idea behind this algorithm is just you have 2 pointers, right? One for the beginning of the array that you're looking at, and then one for the end of the array that you're processing. The one in the front will be the one that you write to, and then the one in the back will be the one that you read from. So in this way, you're trying to take care of the you're trying to basically figure out what the invariant is for each of these loops, and the invariant here is that the back pointer will always be behind the front pointer, because you're always going to at most remove because you're at least going to remove items, but if you don't remove any items, then they'll just be moving in lockstep. Okay, so let's do that, I suppose. How do I want to implement this? So let's say for index in range of n, I always like to set n is equal to length of the nums. I think this is okay, but maybe I want to do n minus 1 so that we don't do more than that, or maybe even n minus 2. And you'll see why in a second, which is that because I want to do something like if index if index is equal to num sub index plus 1 is equal to num sub index plus 2, then I think that's right syntax. I'm not sure actually. I think that is right in Python, but I could be wrong. So I just let me save, and then the front pointer is equal to 0. Set that. So if this is the case, well, if this is the case, then we don't want to write index plus 2. Actually, let me just rewrite this for a second. Let me start from 2 instead, so that our indexing makes a little bit more sense. Maybe. And you go from index is equal to -1 and -2, and then now I would say that you always write the first 2 elements, because no matter what, you cannot have 3 ways for the same number. If you have, the first 2 number cannot have 3 numbers being the same number, right? So you could skip the first 2 because effectively you write to the first 2. So actually, let's start the front at 2 in that case, and then now you have nums. If this is so we want the inverse of this, and if you remember your logic, this is actually modus tollens, I believe, or one of those things, or maybe it's De Morgan. I always confuse them, but in any case, you could just invert the logic, and feel free to leave in the comments what the name of that actual logical operational switch is. But okay, so then that means that if this is the case, that means that you're able to get this from num sub index, and then front increment by 1. right? Because in any other case, well, the only other case is that num sub index is equal to num sub index minus 1 and num sub index is equal to num sub index minus 2. And in that case, that means that you have at least 3 numbers in a row, so you don't want to write in that case. But so the opposite of that, the inverse of that, is that you want to write, which is what I did here. And that's pretty much it, I think. Because I think that's the number you want to return, and because you do it in place, I think that's all you need to do. Let's give it a spin. Let's give it a twirl. I seem to be having an off by 1. Maybe my logic may be a little bit off for the 3 of a kind, but because this is clearly off. Let me look for my logic again. Because if it is equal to both, then you don't want to write, right? So okay, maybe I messed this up. Right, in this case we don't want to write, so let's change a not to this. Does that change my answer? That is interesting. So we start with 1 1, we get the 1, we skip, and then 2. Oh, I see. Because what happened here is that I messed up. So the last 2 number is not the last 2 number in the adjacent array, but the last 2 numbers, the last 2 numbers you wrote, right? So this is actually front minus 1 and front minus 2. Okay. Whoops. Okay, there we go. Let's hit the submit button. So the tricky part about this problem is, okay, I was going to say get it right because if I get a wrong answer, but the tricky part of this problem is getting it right, but also just thinking about the invariance of this problem and thinking about your pointers. In my case, I confused the pointers for half a second, which is why the index and the front. But as soon as I get that, because basically the idea is that, okay, you have an index, the current index in my code, this is the candidate for whether we want to add this number, right? And we want to add this number if and only if the last 2 numbers that we added are not equal to this number, because then in that case, you have a third number that's the same. Yeah, cool. I think that's what I have with this problem. It's linear time, I guess constant space because we manipulate the input. Yeah, I mean, I think I don't really have much more to say. I mean, it's a little weird. It's a little bit, constructed in a very forced way in the in-placeness of it. Usually you have the extra space, or 1 extra space is not necessary, though in an interview maybe they'll ask for that. But in place algorithms are always a little bit tricky with respect to why that is. Yeah, I don't know. I want to say that this algorithm is not super interesting, but this concept does come up in play a lot with respect to with respect to 2 pointers algorithm. So definitely practice your 2 pointers algorithm. I think that would be my takeaway for this problem. That's all I have. Let me know what you think. I will see y'all tomorrow and have a great whatever. Bye bye.